Hey everyone, and welcome. Today we are jumping into one of the most powerful and sometimes misunderstood features in C#, reflection. It's this wild idea of code that can actually examine itself. This is the key that unlocks so much of the modern, flexible software we all depend on. So let's pull back the curtain and really see how this thing works.
All right, so we're going to start with this core idea. What if our code had a kind of self-awareness? This whole metaphor of code looking in the mirror is really the key to getting a handle on everything else we're about to cover.
Just let that sink in for a second. We're not just talking about code that executes commands. We're talking about code that can pause mid-execution and inspect its own structure, its own capabilities, basically its own DNA, all while it's live and running. That is exactly what reflection lets you do.
So, what is this powerful tool really? It's time to stop talking in metaphors and get a clear, straightforward definition. Let's really pin this down.
And there it is, the textbook definition. It's all about inspecting and interacting with its own metadata at runtime. Now those are the two magic words here. Runtime means while the program is actually up and running, not before. And metadata, well, that's just the data about your code. But let's break that down even more. Imagine handing your application a magnifying glass while it's running. It can now peer into its own code, figure out what classes and methods it has, and even decide to use them on the fly. It's a program that can literally learn about itself. So what can this magnifying glass actually see? Well, just about everything. It can look at entire assemblies, the compiled DLLs or EXEs. It can zoom in on specific types, like your classes. And it can even peer inside those classes to find all their methods and all the properties that hold data. It gets a complete blueprint of itself. Okay, but here's the catch. As with any great power, there's always a trade-off. Reflection is incredibly powerful, for sure, but it's not a tool you want to use for everything. You have to be really smart about when and where you use it. And this is where that trade-off gets really clear. On the one hand, you get this amazing flexibility. You can dynamic code, build generic frameworks that can work with code they've literally never seen before. But on the other hand, there's a big performance cost. It's way slower than just calling a method directly. It can break the rules of encapsulation by accessing private members. And because the compiler can't check your work ahead of time, you're opening the door to some nasty errors that only show up when the program is running. This quote just nails it, doesn't it? It's the core dilemma of reflection. The power is huge, but it comes at a price. And that biggest price is almost always performance. It's the #1 reason developers are so cautious about reaching for it.
All right, that's enough theory. Let's see what this actually looks like in practice. How do you tell your code to pick up that magnifying glass and start looking around? Let's get our hands dirty.
So imagine this scenario. Our program needs to work with the person class, but we don't have its source code when we build our app. Maybe it's part of a plugin that a user is going to load later on. How in the world can we interact with it?
It all comes down to this 4-step dance, all done dynamically. First, we get the type. That's the blueprint for the person class. Next, we use this cool activator class to create an actual object from that blueprint. Then we ask the type, hey, do you have a property named name? We get that property back and use it to set the value to John. And finally, we do the same thing for a method. We ask for the sayHello method and then we invoke it. The key here is that we did all of this without ever writing new person or person.name directly in our code.
Now, while this might seem a little abstract, this exact capability is the engine behind so many of the tools and frameworks you probably use every single day. So let's talk about where this power becomes absolutely essential. So given that performance hit we talked about, you have to wonder, why would anyone even bother? When is this kind of dynamic power not just a nice-to-have, but an absolute necessity? The answer is you find it everywhere that flexibility is king. Plugin systems use it to load and run code that didn't even exist when the main app was built. Serialization libraries like JSON converters use it to inspect your objects and figure out how to turn them into text. ORMs, the tools that map your objects to database tables, completely rely on it. And even unit testing frameworks use reflection to automatically find and run all of your test methods. In every single one of these cases, the need for that dynamic behavior is just so important that it outweighs the performance cost. And that really brings us to the final thought here. Reflection gives you this incredible power to write code that can adapt, explore, and evolve, but it demands caution in return. It's the engine that powers truly extensible modern software. So the real question for you is, in your next project, when you need that ultimate level of flexibility, is the power of reflection going to be worth its price?